special review, the one of the 60 integrals, but I only want the first 30. Okay, the first 30 integrals, not all of them. And on Friday, you have the next quiz. Quiz number 3 is going to include all 5 topics: definite integrals, the properties, which is 9.1.1, second theorem, which is 9.1.3, Riemann sums, and both topics from this week, which will be area under a curve and area between curves. Okay? Yeah. No, that is 9.1.1. Riemann sums, yeah, that's
Definite integrals are just the ones with numbers, right?
Yeah, same thing as we haven't done, but the properties, I mean, for example, when you have the properties and you need to change the sign or get the values. 9.1. Okay? Fine. Ready? Okay. I know that you had your entire week occupied, you didn't study anything. Well, perhaps. I hope that you had fun with your rallies and everything. Your topics week. I hope. Perhaps. But this topic is basically a continuation of the previous one. So it's basically like a review of the previous one. So that's a good way to start it. In case you forgot everything, it's going to refresh your memory. The topic is called area under a curve. And you remember I already defined what was that, right? The idea is that we're going to use definite integrals to find the area bounded by what? By the function, 2 vertical lines, x equal to a, x equal to b, and the x-axis. Okay? We already solved that. But today we're going to, change things a little. The principal thing to see today is that you're also going to graph the area. You're also going to graph the function. What kinds of graph we're going to graph? Basic ones. Polynomial, like parabolas, cubic functions, trigonometric ones, sine, cosine, exponential, logarithmic, rational functions. Okay? So in case you forgot how to graph them, well, I recommend that you study, especially from the last semester, you had a support with all the graphs. If you don't have them, I'm going to put it in Blackboard later. Okay? So, again, the idea is that now we're going to use integrals to find the area, the real area. Let's do an example. Graph and calculate the area bounded by f of x equal to square root of x, square root of x, x equal to, let's say 0, x equal to 4, and the x-axis. Okay? So that would be the structure. I want to find the area below the curve square root of x between 0 and 4 and the x-axis. The first step is to graph the function. So in this case, for example, do you remember what kind of graph is square root of x? Half a parabola. Yeah. Half a horizontal parabola. Okay. 1, 2, 3, 4. 1, 2. Okay. In case you forgot how to graph that, you can also tabulate. That is, give values to the function. If I were to do that mentally, we have 3 values. When the x is 0, y is going to be 0. When x is going to be 1, y is going to be 1. When x is 4, then 2. Okay? So now you have 3 points. Graph the function. Okay? But then it says the area has to be bounded by that graph, x equal to 0, x equal to 4, all the way here, and the x-axis. So the area that I want will be this. Okay? That's the area. Now, the question is, how do I represent the integral for this? Simple. Area equal to integral from where to where? 0 to 4, yeah, of the function which is square root of x times dx. Remember that dx represents the width of each subinterval, but as an integral, because it's a continuous number of subintervals, just a small change between them. So dx represents that. Dx is like the delta x of the rectangles. Now we integrate integral of this. Well, if I rewrite that,
2
x to the 1/2 dx.
x to the
2/3 x to the 3/2 between 0 and 4, or 2/3 square root x to the cube from 0 to 4. And then solve it. So it's going to be 2/3 square root of 4 to the cube minus 0, because it's 0. So the answer is going to be 4 to the cube, 64 square root 8 times 2/3, 16/3 units. And that's it. Yeah. What? You'll see what. In this case, it's easy, but sometimes the areas are going to be a little more complicated. So you need to get the graph so you can see what happens in those areas. Okay. Questions? No. Alright. Can I read this part? Okay. What happens if you have an area that is divided in parts? What do I mean by that? For example, graph and calculate the area bounded by f of x equal to 1 minus x squared, x equal to minus 1, x equal to 2, and the x-axis. Okay. Okay, so now I have the same thing, but now the function is different. 1 minus x squared between x equal to minus 1, x equal to 2, and the x-axis. Before we graph, try to visualize what kind of function, what kind of graph corresponds to that function. An inverted parabola, yeah, with concave downwards, but it's shifted, right? Yes. How much or how many spaces? Left? No. No, not left. It's 1 up. For it to be left, it has to be inside the square. Like, for example, x plus 1 all of it to the square, that means to the left. But in this case, it's 1 outside the x square, means that it went up. Minus concave downwards. So, if I were to graph it, say 1, 2, minus 1, minus 2, 1, 2, minus 1, minus 2, minus 3. Okay? So, as we said, parabola, one more important points, the intersections, and another one, root 2 comma minus 3, and 2 comma minus 3. Something like this. Okay? Questions about how to graph this kind of functions? No?
¿Qué no debería ser 2 y en el 4?
Yeah, but if it's 1 up, Ship. Almost. Okay. Careful. You're going to graph, and I want the graphs exact. Please. I'm going to put a little grid with numbers and everything in your quizzes, but I want the graphs exact. Okay. Okay. So, what will be the area that I need to shade in this case? If it says between -1 and 2, it says has to be this part and all the way to this part. Why those? Because of this, of the x-axis. This axis is also a boundary. So it's bounded by the x-axis, the parabola, -1 and 2. So that's why it's not this part, it's this part because it's bounded by the x-axis. Why not that part and this part? Because it's x-axis and the parabola. When I say under a curve, it also means above the curve. As long as it's bounded by what? By the x-axis and the vertical line that I give you.
Yo entendí eso por el x-axis.
Yeah, like a boundary. Axis, x-axis, this axis here is bounded by that. That's a boundary for the function, for the area. So if it says bounded by the parabola, x equals to -1, x equal to 2, and the x-axis. So it has to be the area that is between those lines. Why not this part? Because this part is all the way below the x-axis, not between the parabola. Do you see what I mean?
Es que, o sea, no entiendo, o sea, como qué parte sabes que debes como seleccionar para el área.
Okay.
Dependiendo del x-axis.
Es que de cuenta, a lo mejor te pierdes por todo este pedazo de acá. Pero esto no me importa, no me importa. ¿Por qué? Porque va de -1, o sea, de -1 hasta 2. ¿Sí? Entonces, en este caso, son mis límites. De ahí no puede pasar. ¿Por qué no agarré esta parte de abajo? Porque me está diciendo que está entre la parábola y el eje X. Si lo pongo debajo de esto, ya no es la parábola, es debajo del eje X y ya. Y se va al infinito. No tiene sentido. ¿Y por qué este paso de acá? Porque ahora es delimitado por el eje X y la parábola y la línea vertical. ¿Sí? Es como, está encerrado por eso.
Sí.
Si yo agarrara lo de abajo, ya está encerrado. Se va hasta el infinito, no me sirve.
¿Y no podría estar arriba? O sea,
¿Arriba de dónde?
en lugar de que fuera por debajo, no podría estar arriba.
¿Te refieres a eso?
Ah, eso que estuviera arriba, o sea, como a partir del 1.
No, porque arriba no hay nada. Está delimitado por la parábola. Arriba no hay parábola. Está por eso es delimitado por la parábola y el eje X. Entonces tiene que estar encerrado por eso. Si lo pongo encima del eje X, ya no está encerrado por la parábola. Ya se fue por otro lado. No tiene sentido. ¿Ok? Fine. ¿Sí les queda claro o todavía no?
Sí.
¿Sí? Entonces, vean también cómo vemos con lo de Riemann-Sums. Lo de Riemann-Sums es dibujando que rectangulitos. Un rectangulito debe tener una cierta altura. Si lo pusiera por arriba, ¿dónde acaba el rectangulito? Pues no acaba. No tiene sentido. ¿Sí? Está encerrado por esos 4 límites. Este y este. Ok. Fine. Now, that's one of the problems. Yeah. There's another problem. There are 2 parts. This part here and this part there. If you were to say without graphing that the area is between -1 and 2 of the function, which is this one. If you were to say this is the integral, this is wrong. Why is that wrong? Because if you remember, we did an example when you have an area below the x-axis. What happened with that? If you were to get the integral from here to here in a single integral, this part subtracts this one. And that's not the area. I don't want that. Okay? So what do I need to do? I need to calculate the integral for each part of the areas. And the ones that are below the x-axis, you need to change the sign. So it no longer subtracts, it adds to the other area. So in this case there are 2 areas. Let's call this one area 1, this one area 2. So area 1 is going to be from minus 1 to 1 of the formula, 1 minus x squared dx. The second integral is from 1 to 2. But when I get the final area, I need to subtract. Area 1, total area, would be the area 1 plus, you could say, absolute value of the area 2. So we get rid of the minus sign. Or just change the sign if you want, basically. Okay? That's why you need the graph. If you don't have the graph and you just assume it's a single integral, sometimes it works. So you need the graph. And be careful because in the quiz there will be something like this. Most probably.
Es siempre que el área esté debajo del eje de X.
Change the sign. Change the sign.
Solamente el cambio significa.
Yeah. I put absolute value because it means that it's going to be positive because an error is always positive. Same thing.
¿Cómo seleccionamos esa lista? ¿Cómo se configuran los cargos?
Because that's the point where the areas change from one to another one. That's the point that I need to put as a new link. This area, which is above the x-axis between minus 1 and 1. The first one. The second one from 1 to 2, which is the end point of the limit. But as an absolute value, because it's below the x-axis, you need to change it. Okay?
Profe, ¿y por qué no le total ahora se suma?
Just like we did in the other activity, remember? We need to add all errors.
Ah, ya no es como la pasada que se restan del...
Es que si te acuerdas, había una actividad que venían dos preguntas. Una actividad de 7, había una figura y te decía, encuentra el área, inciso A, inciso B, encuentra la integral definida. Como área, simplemente sumabas todas, pero como integral tenías que restar la actividad por debajo. Es lo mismo.
Tomé como si fueran límites cada uno,
Pero es lo mismo, o sea, realmente nada más es sumar todas las áreas. El único problema es esa parte. Le cambio el signo para que la pueda sumar. O me olvido del menos, como quieras verlo.
A ver, ¿podemos resolver?
So, for the area 1 is going to be integral. Integral of that, x minus x to the cube over 3 between minus 1 and 1. So that's going to be 1 minus 1/3 minus 1 plus 1/3, and that's equal to 2 minus 2/3 equal to 4/3. Yes. That's the first area. For the area 2, same solution, different values. So it's going to be 2 minus 1/3 minus 1 minus 1/3. That would be 1 minus 7/3 equal to minus 4/3. That's if I just solve it with the 1/2. When I get the final area, it's going to be 4/3 plus the absolute value of that one, or just the positive part, equal to 1/3. Do you see what I did? I just got the value and it's negative. Why? Because in the integral, below the x-axis is negative. But to find the area, I change the sign to positive with absolute value. And add it. That's it. 1, for example, is inside the x squared. Let's say you have x plus 1 to the square, everything to the square, then you shift to the left or right. When it's outside the x squared, it means that it's going up or down. Positive up, if it's negative down. This minus only tells you that it's going to be reflected. Yeah. Good. Let's try another one. Remember trigonometric functions?
Yes. Sometimes.
You should, yeah. Okay. Remember, in the quiz and in the exam, there could be parabolas, cubic functions, sine, cosine, exponential, logarithm, and rational also. Okay, in this case, for example, you have y equal to cosine of x between minus pi over 2 to pi and the x-axis. Remind me please, how can I graph cosine? Starting from where? 1. 0, 1, yeah. So, for example, in this case, this is the 0 minus pi over 2, pi over 2, and pi. 1 minus 1. Okay? So, like you said, okay, 0, 1. So 0, 1. When it's pi over 2, will be 0. When it's pi, will be
-1.
minus 1. When it's minus pi over 2, will be 0. So the graph, just for that part, will be all the way. Okay? Between minus pi over 2 and pi, so the areas that I need to shade will be all of this and this. Same problem as that one. We have two areas. Area 1, area 2. Area 1 given by integral from minus pi over 2 to pi over 2 of cosine of x dx, and the second one from pi over 2 to pi cosine of x dx. Okay? Integral of cosine? Positive or negative? Positive, yeah. So, sine minus pi over 2 to pi over 2. So it's sine of pleasure minus sine of minus pi over 2. Sine of pi over 2 is what?
1.
1, yeah. Minus sine of minus pi over 2 is what? Minus 1. So the answer is 2. If the answer is 0, it's not logical, right? So be careful with that. You may use a calculator if you want to, but be careful. It has to be in radians. Okay? The other one, sine of x from pi over 2 to pi. So it's again sine of pi minus sine of pi over 2. Sine of pi is what? No? 0 minus 1 equal to minus 1. But I don't want that, so it's going to be total area 2 plus minus 1 equal to 3. Okay?
Siempre hay que poner la U, ¿verdad, profe?
If it's all areas, yeah. You will be enough. You, that will be fine. Questions? No?
Mariano, te queda el 10%.
Okay. Now, one more thing. In these areas, so far, those are areas with respect to x. What do I mean by respect to x? That the x-axis is my boundary. But there are sometimes that my areas will be with respect to the y-axis instead.
¿Se puede?
Yeah.
Pero.
With what?
No, no.
Don't worry, you'll see.
Tengo que ver para que.
Yeah, you will. And there is this.
Pero es que no se cerraría el área, ¿sí?
¿Ah?
No se cerraría el área.
Sí. Okay. Respect to y. Imagine this situation. Graph and calculate the area bounded by x equal to y squared, y equal to 0, y equal to 2, and the y-axis. Okay. In this one, for example, the question is graph and calculate the area bounded by x equal to y squared, which is a function in terms of y. Y equal to 0, y equal to 2, which are horizontal lines, and the y-axis. Okay? This example is easy because the function is already in terms of y, but sometimes the function will be in terms of x, and you need to change it to y, which is, let's say that is fun. Okay, so in this one, for example, I want to graph that. What's the graph of x equal to y squared? What kind of graph is that?
Just
A what? Rational? No.
Like a parábola, pero
Horizontal.
ya,
So it's a parabola.
como tirada.
Yeah, it's a parabola. No, well, actually this one is a complete parabola.
Pero está como si completaras la raíz
Oh
cuadrada.
yeah, exactly. One, two, three, four, 1, 2, minus 1, minus 2. Okay, again, x equal to y squared is a parabola. It's an horizontal parabola. There are no transformations in this one. Just a basic parabola, but horizontal. 0, 0, 1, 1, 1, minus 1, 4, 2, and 4, minus 2. So the parabola will be something like this. Remember that from Math 3? Yeah? So, in this case it says, bounded by that parabola, bounded by y equal to 0, y equal to 2, and the y-axis. So this time my area is not below the parabola. It's going to be, exactly, from 0 to 2, and the y-axis is going to be something like this. Okay, so that's my new area. Now it's to the left, because it's bounded by y-axis 0, 2, and the parabola.
It's the same with the sun. Si sacáramos el área de lo de acá abajo, también haríamos lo mismo con el signo.
Well, in the particular case, no, because the problem with the y is when it's left to the y-axis instead of right. If it's right, it's like positive in this one. In this case, there's no problem because all the parabola is to the right of the y-axis. Okay? Did you get that?
Yes.
Okay. So remember, you also need to know how to graph functions in terms of y. Yeah. Okay. So a single area equal to integral from where to where? 0 to 2 of the function which is y squared, not x, y squared, dy, exactly, dy. Why dy? Because dy now is the what? The width of the rectangles horizontally. Dy is this. And then we integrate that. Y to the cube over 3 from 0 to 2 equal to 8 thirds minus 0 equal to 8 thirds. Yes. Okay? Questions?
It's just like move the graph.
Well, this is easy. It's already given in the y-axis in terms of y. If I give you the function in terms of x, but it's still in terms, if it's still the area is respect to y, you need to change the function.
Como like poner el punto que está acá en el hombro.
No, no, exacto. Yeah.
O sea, no se puede que te digas lo mismo, pero en lugar de y, que sea x, se puede sacar.
X-axis?
O sea, que sea como la misma función, pero que sea.
Posiblemente sí, pero tiene que corresponder esto con esto. O sea, bueno, en la actividad de algunos está medio truculenta que se les dice así y luego en x acá, pero a mí se me hace como que no, yo les pondría que tenga sentido, o sea, si tiene y 0, y lógico con el eje y. Lo que sí puedes variar es la función, eso sí, pues sí puedes despejarlo, pero esto no es un ejemplo, pero esto sí va a corresponder, tal cual. Okay, questions? No? Okay, let's do one last example. ¿Ah?
Sí se puede. Neta me va a deber como 5 millones.
Desde aquí, desde el cero.
Profe, en el quiz podrían venir gráficas de cotangente y tangente.
Sale cosa. the same? Okay. This one. Last example. Let's try at least to set the integral. Even though maybe we don't solve it, but at least set the integral. It says, graph and calculate the area bounded by y equal to e to the x plus 2 minus 2, y equal to minus 1, y equal to 2, and the y-axis, okay? By having this, you know that the graph is going to be with respect to y. But you have the function in terms of x, okay? So first, let's try graphing this directly in terms of x. Know how to graph that? No?
Like this.
You should, but if you don't.
No, así no es.
Okay, fine, pay attention. What I'm going to do is use transformations for this, okay? Remember that the function e to the x has special points. 0, 1, 1, 2.7, the base e. Remember that? Yeah, okay. And the graph will be something like this, right? That's the graph for e to the x. But you have what? You have transformation. 2 to the left, 2 down. Okay, so it means that for this point we're going to move 2 to the left and 2 down. 1, 2 to the left, 1, 2 down. 1, 2 to the left, 1, 2 down. Okay? I repeat. Initial points 0, 1, 2.7. 2 to the left, 2 down. What else? There's an asymptote at minus 2. So an asymptote here, right?
Why is there an asymptote?
Because exponential always have asymptotes.
No, okay.
So the graph is going to be something like this.
Pero yo no, o sea, 2 a la izquierda.
Let's listen to be 3 instead of 2. 3. ¿Ah?
Yo no entendí cómo sacaste los puntitos para.
Siempre hay puntos especiales. Alex tiene puntos especiales. 0,1 y 1,2.7. Pero este es
Siempre son esos.
2 a la izquierda, 2 abajo. Esos puntos que encontré, los muevo que 2 a la izquierda, 1, 2 a la izquierda y luego para abajo. 1, 2 para abajo. Con cuadrículas más fácil, no tengo cuadrículas, por eso quedan así. Y aparte tengo una área horizontal en menos 2. ¿Por qué? Porque originalmente a la x tiene una en y igual a 0 y la bajo 2.
Y el otro puntito,
¿Cuál puntito? Lo tenía. Lo movió a la izquierda y para abajo.
así ya está.
Sí, 2 para la izquierda, 2 para abajo. ¿Sí?
Entonces el área es todo eso y el pedacito.
Ok.
es 3.
So, between minus 1 and 3. So, area here and area there. Okay?
Does the graph cross
Should, well, we'll see. We need to check that.
Profe, ¿qué pasaría si entre tus límites está la asíntota?
No, then it becomes an integral that we won't see this semester. It's called una integral divergente. Integral infinita.
Como las películas.
Okay. Listen. We're not really sure if there's a point here between this one and this area. We're not sure of that. So we need to find this point. How do we find this point? This is the y-intercept. How do I find the y-intercept? X equal to 0. So y-intercept for this function, x equal to 0, y equal to e to the square minus 2. So y is equal to e to the square should be 2 is 5.4 approximately. So no. Actually, this one is going to be all the way up. 4